Now let us start the next section 1.7, which is list upper bounds. So you might have seen the concept of least upper bound in your first year class of calculus. So the definition: bounded below and bounded above set. So the definition: the subset A of R is bounded above if there is a real number, there is a number n such that x is less equal n for every x belongs to A. Similarly, the subset A of R is bounded below if there is a number, real number m, such that m is less equal x for every x in A. And bounded set if subset A of R is both bounded below and bounded above, is both bounded below and bounded above, then we say A is bounded. The next definition is upper bound and lower bound. The definition is: if A is subset of R which is bounded above, then n is called an upper bound for A if x is less equal n for all x in A. And if A is subset of R which is bounded below then a real number m is called a lower bound for A if m is less equal x for all x in A. So we know that there can be infinitely many lower bounds and infinitely many upper bounds if a lower bound or upper bound exist, right? For example, the set 1/2, 1/3, 1/4, 1/5, 1 by 6 and so on. So what can be lower bound and upper bound for this set? So it is decreasing sequence of real numbers and it will converge to 0, right? So the largest real number of this set is 1/2 and the smallest real number, it cannot be we cannot say it is 0, but all the elements of this set are definitely greater than 0 and all the elements of the set are definitely less equal half, right? So lower bound 0 or any real number less than 0, right? So similarly upper bound half or any real number larger than or greater than half. So there are infinitely many lower bounds and upper bounds. So the next definition is there are many lower bounds and many upper bounds. So we define least upper bound and greatest lower bound. So least upper bound so try to write down the definition of least upper bound and greatest lower bound. And then because you have done these definitions also, then let me take some example. If I take example, if I take set A equal to I, set of positive integers, then the least upper bound does not exist because set of positive integer will have elements 1, 2, 3 and continuously the positive integers. The upper bound itself does not exist. So how the lowest of the or lower of the upper bound will exist? And definitely greatest lower bound is 1 because any element, any real number 1 or less than 1 will act as a lower bound for this set of positive integers and 1 is greatest of those lower bounds. Then if I take A equal to 3, 4, then definitely least upper bound is 3 and least upper bound is 4 and greatest lower bound is 3. So if we consider empty set, then what you can say about phi is bounded. Since phi is subset of any say phi is subset of bounded set, so phi is bounded, but any real number A, so let me take B to R, is an upper bound for phi. So it does not have a least upper bound. Similarly, also any A belongs to R is a lower bound for phi. So it does not have a greatest lower bound even though it is bounded. The least upper bound axiom is if A is any non-empty subset, of R that is bounded above, then A has a least upper bound. In set of real numbers R. And the one theorem is there. If A is any non-empty subset of R that is bounded below, then A has a greatest lower bound in R. So the proof, what A is any non-empty subset that is bounded below. So let A is subset of R which is bounded below. So let B is subset of R such that real number x such that minus x is element of A. So it means nothing but that is elements of B are negative elements of B, negative elements of A, negatives of elements of A. So suppose if M is lower bound of A, then minus M is an upper bound of B. So for if x is in B, then minus x should be there in A. So M less equal x implies x less equal minus M. Hence B is bounded above, and B has a least upper bound. So let suppose Q is the least upper bound for B, then minus Q, the negative of Q will be the greatest lower bound for A, and this is the then A has greatest lower bound in R, right? So